x squared. I don't do this with my calculus class, regular class, because we have other methods in that class. So with second and table, I'm just going to go as far negative as I can. So I'm going to say negative 20. It's already very small and positive. So it appears that this is going to be 0. E to negative 41 is really 0. Okay. So there is really no point in going further negative. Okay. As you see, the calculator cannot even compute. It's so small. Negative 1,000 now. It can't compute. It's so small. Okay. So in this particular case, this is 0. But when the limit, when x approaches infinity or negative infinity, is a number, in this case 0, what do we conclude? What do we know immediately? And we have to write it on paper. What does this mean? When x approaches negative infinity and the y value approaches 0. Y values approach 0. What does that mean?
Is it a vertical asymptote?
Remember, a vertical asymptote is when the function is undefined. So once you gave me the domain negative infinity to infinity, I immediately said, then there are no vertical asymptotes. So you're close.
Horizontal asymptote.
Yes. So y equals 0 horizontal asymptote only at negative infinity, not at positive infinity. Okay. So now we are ready to analyze the first derivative. Again, this is not a pleasant situation. So f of x equals x squared e to 5x. What differentiation rule we apply here?
Product rule.
Very good. So the first function prime. So the first function prime is 2x e to 5x plus the second function times this one prime. Can anyone give us e to 5x prime?
I have e 5 to the x.
Very good. Awesome. Yes, of course, I have to clean it up and I will factor out x e to 5x. If I don't, I will not know what to do next. So when x is outside, e is outside, so there is a 2. E to the x is outside, 1x is outside, so 5x inside. So now f prime set equal to 0 because f prime will always be defined. And we get two options. Not from this. Remember, e to 5x can never be 0. So what are the options? Again, this is just quadratic equation.
0 and negative 2/5.
Excellent. Thank you very much. And negative 2/5. 0 from here. 2 goes to the other side. Becomes negative. Divide by 5. Negative 2/5. Excellent. Thank you so much. So these are the values that I have to put in the table. Here they are. So please remember to write 0 for the first derivative and for negative 2/5 also 0. So some of you are using the table, but you did not write 0. You have to write 0. The first derivative is 0 at negative 2/5 at 0. So now I have to study the sign of the first derivative. Some of you are studying the sign of the function. No, this doesn't tell us anything. So please do not study the sign of the function. Who cares? The sign of the first derivative will tell us something about the function. So I'm going to plug in negative 10, negative 0.5. No, this is negative 0.4. So negative 0.1 and 10. I'm not putting them in the table because I'm not going to use them. I'm going to use them for the sign only. So I just want to put a different color here. So I'm going to use negative 10. you're going to use negative 0.1 right here, and I'm going to use 10. And you can put this in the graphing calculator. But remember what you put in the graphing calculator. You have to put in the derivative. What was the derivative? X e to 5x. There is no need for e to 5x. It's always positive. So let's not even put it in. And 5x plus 2. Because it's always positive. It's not going to affect the sign. Okay, so second and table. I plug in negative 10, as I said. I'll plug in negative 0.1, as I said, and I plug in 10. I need a sign for a positive, negative, positive. That's all I care about. Positive, not for the function, just the derivative. Negative, positive. I need to plug in the function this number to find this point in the function. So in x squared, e to 5x, I have to plug this in, negative 2/5. So x squared, I didn't mean that. What did just happen? X squared. Anything happens here? It's because it's so far away from me I can't see. Yes, okay, finally. E to 5x. Okay, so I plug in negative 0.4. It's negative 2 divided by 5. Okay, so it gave us an ugly number, 0.002. 0.02. That's it. That's good enough. Okay, so now I have to make sense of this first row and make sure that it works well with the second row. Now I know if these don't go well together, then I have an error. Okay. From 0 to 0.02, the function is barely increasing, but it's supported by the sign of the first derivative. From 0.2 to 0, it's barely decreasing, but it's indeed supported by the sign of the first derivative. From 0 to infinity, it's increasing. Is that supported? Yes. So now I know that these two work well together. Again, we are only studying the sign of the first derivative, not the sign of the function. The function indicates increasing, decreasing. Okay, so because this is a critical number and the function increases and decreases, this point is a relative max. Because this is a critical number and the derivative, not the function, the derivative changes sign from decreasing to increasing, from negative to positive, this is a relative min. And now, of course, this is even more difficult. It's the second derivative. Again, do not ever look at the second derivative if you don't have to. I know the book emphasizes the second derivative test. It's a waste of time. Okay, so the first derivative, I'm just going to clean it up a little bit. So 2x e to 5x plus 5x squared e to 5x. As you've noticed, there is a lot of work with these e's. A lot of work. Okay, so let's find the second derivative. So the first function prime is 2 e to 5x plus 2x times 5 times e to 5x. And here we have positive 10x e to 5x plus 5x squared times 5 times e to 5x. Yes, I did that quite fast because I applied the product rule twice. I applied the product rule here. I applied the product rule here to get two terms. Yeah, these problems are way too long for a test situation, but we have to show in class a couple. I have no choice. Okay, so then the second derivative, what will it be? Let me clean it up a little bit. 5x. So this is 10x plus another 10x. So this is 20x e to 5x. And this is plus 25x squared e to 5x. So e to 5x, 25x squared plus 20x and plus 2. So let's see if this one has solutions. Negative b plus or minus the square root of b squared minus 4ac. I hope it doesn't have solutions. That's my hope. So I was just thinking whether it's factorable, but it's not factorable. So how much is 8 times 25?
200.
I hope. I'm sorry?
200?
I was hoping it doesn't have solutions. You're right. Okay, if that's the case, so it's 10 the square root of 2 divided by 50. So I have to approximate these two solutions and put them in the table. Okay. Let me go to the share my screen. Okay. So I think I showed this. Let me show it again here. We go to number 9. So go to apps and then number 9. And we can solve a polynomial equation, which is quadratic in this case. I just wanted to give me the solutions. The first coefficient is 25. The second coefficient is 20. You can do this. I'm happy in this class. If you don't write the quadratic formula, I'm happy. But you have to write the equation correctly, though. Okay, so both solutions are negative, and look how close they are. Negative 0.11, negative 0.68. Wow. I'm so glad that they're not asking us to graph this function. So we have x equals and x equals. And these are where the second derivative is 0. Okay. So of course they had to be negative 0.11 and negative 0.68. Be very careful where you put them in. Negative 0.68, negative 0.4, negative 0.11, 0. So now I have to study the sign of the second derivative. But because right here in the middle there is a relative max, I don't need to use the second derivative test, right? Or I can plug in. It's not a difficult situation. I mean, I have to put in this function in the graphing calculator and plug in numbers. To the left of negative 0.68, between these two, not easy, like negative 0.3, and so on and so forth. But if this has a relative, if there is a relative max, then the function, the second derivative, has to be negative. If there is a critical number here, and it has a relative min, so the function has to look like this. What I don't know is this piece, because I don't have a critical number here to go by. Here I went by the relative max. Here I went by the relative min. But I don't know what's happening here. But that's okay. So I can plug in the function negative 10 here. Negative 10, negative 10. This is positive. I wouldn't worry about it. So with negative 10 here, it will be positive, a huge number. This will be negative 200, so this is positive. I checked. So the function holds water. Okay, so then the interval, very difficult to read even, right? Because the numbers are so ugly. So the function is increasing between negative infinity and negative 2/5 and between 0 and infinity. It has, and I have to determine this. So I have to determine this value and I have to determine this value because they are inflection points. But I have to plug in the function negative 0.68 to get this number here, and negative 0.11 and get this number. So I can find the inflection points. Any questions? As you see, there is a lot of work with these problems, especially
in the bloodstream decreases with time t in hours. Okay. Suppose that under certain conditions, A is given by, we are given the function A0, the initial, t squared plus 1. Where A0 is the initial amount of medication, assume that an initial amount of 100 cc is injected. So this is initially 100. And t is in hours. Okay. Find A of 0, A of 1, A of 2, A of 7, and A of 10. This is part A. Find the maximum amount of medication in the bloodstream over the interval, of course, 0 to infinity, because t is in hours. And then they say graph the function. Okay. Is it okay if we skip this? We are just going to put the function in. A of t equals 100 divided by t squared plus 1. We'll put this function in the graphing calculator. We'll plug in 0, we'll plug in 1, 2, 7, and 10, and get different values. Is that okay?
Yes.